All right, Unit 6, Similarity Practice Quiz. Number 4. The length of a rectangle is 20 meters and the width is 15 meters. Find the ratio of the width to the length of the rectangle, then simplify the ratio. So very important to see how they're asking you the question. You want the width to the length. So from this number to this number. So it's going to be 15 meters to 20 meters. And that simplifies to 3 over 4. Okay, that's the ratio, 3 to 4. Number 5, the measures of angles in triangle UVW are in the extended ratio 1 to 2, 1 to 1 to 2. Find the measures of the angles. So here, for example, we have UVW. So the ratio is 1x to 1x to 2x. Now remember that in every triangle, the sum of the degrees of all three angles is 180. So x plus 2x is 180. So 4x is 180. 180 divided by 4 is 45. So if x is 45, the measure of angle U is 45. The measure of angle B is 45. And the measure of angle W is 2 times 45, which is 90 degrees. Number 6, find the geometric mean of 8 and 12. So to do that, put into the you put into the formula, you multiply both numbers, and then you find the square root of those two numbers. Okay. Now, I'm just going to rewrite it since I know we're multiplying here. Well, if you multiply 8 times 20, if you multiply 8 times 12, you get 96. And 96 doesn't really have a perfect square root. Okay, so I'm gonna play around with the numbers to make it easier to simplify. Okay. For example, I know 8 is the same thing as 4 times 2, so I'm gonna write it that way, or 2 times 4. And I know that 12 is also 4 times 3. So I rewrote it this way. So now I'm gonna pair up the 4's together. 4 times 4 is 16, and then 2 times 3 is 6. Okay. And if I separate these, I get square root of 16 times the square root of 6, and I know that the square root of 16 is 4. So your answer is 4 times the square root of 6. Next, number 7. In the diagram, BA over DA is equal to BC over EC. We need to find BD. Okay, so let's go ahead and take this proportion here and let's substitute. BA is from here all the way to here. So that's actually x plus 3. DA is 3. BC is from here to here, so 8 plus 2, that's 10. And EC is 2. Okay. Now that I set up my proportion, I'll go ahead and cross multiply to solve. So it's going to be x plus 3 times 2 is equal to 30. I'm going to use the distributive property. 2x plus 6 is 30. Subtract 6. And then divide by 2. So So X is 12. So that's BD. BD is 12. Okay. Number 8. Given that CD over DB is equal to CE over EA, find CD. Okay, so CD doesn't have that value here, so I'm gonna put an X there. Okay, so now I'm gonna substitute CD is X, DB is 5, CE is 10, and EA is 4. Now that I have my proportion, go ahead and cross multiply. So 4x is equal to 50, and 50 divided by 4 is 25 over 2 or 12.5. Either one of those is fine. All right, number 9. We're going to use the AA similarity postulate to show that the triangles are similar. We're going to go ahead and write this proof. So we need to AA. So we have to show that two angles are congruent. Okay, so we could start off with what's given. We could see that T and Q are both 35-degree angles. So angle Q is congruent to angle T. That's given. That's one of the pairs of angles. Now remember when you have lines that intersect, like here in the middle, you create vertical angles. So angle RSQ is congruent to angle TSU. That's because they're vertical. Okay. Now, since I have angle, I could say that the triangles are indeed similar. So triangle QSR is similar to triangle TSU. That's because of the angle similarity theorem. Okay, moving on, number 10. My teacher again. All right, for this one, we're going to use the side angle side similarity postulate. Okay. So first, let's find the angle that's the same. Well, actually, if it helps, you could separate the triangles. Okay. And I'm just going to go ahead and do that. I'm going to draw the small triangle here, which is CBD. And then I'll draw the bigger triangle over here, which is CAE. And then CA is 8 plus 4, which is 12. And CE is 3.5 plus 7, which is 10. Okay, so first, we could see that both triangles have angle C. So angle C is congruent to angle C. Um, that's the reflexive property. Okay, so we have the angle part. Now we have to show that the sides that make those angles are proportional. Okay? So this 4 here corresponds to this 12. And this 3.5 corresponds to the 10.5. Okay? So let's go ahead and compare those. So CB, let's do this in green. CB over CA is 4 over 12, which is 1/3. And then CD over CE is 3.5 over 10.5. And here I could divide the top and the bottom by 3.5 to get a 1 over third as well. So this equals your corresponding. Here, corresponding. So we could see that the sides are proportional because they're equal to the same fraction. So we could see, now we could say that the triangles are similar. So triangle CBD is similar to triangle CAE. By the side, angle side, similarity postulate. And last one, number 11, we're going to use side similarity postulate to show that the triangles are similar. Again, I'm going to separate the triangles. Well, we can see the smaller triangle here. That one's easy to see. Now the bigger triangle, I'm just going to redraw it over here as TSQ. So ST is 15. TQ is 9 plus 4.5, which is 13.5. And then SQ is 7 plus 14, which is 21. Okay, so I'm going to compare this aqua triangle to the purple one. So let me go ahead and make my T-chart first. So for side, all three sides have to be proportional. So when you simplify the corresponding sides, all those fractions have to be equal. Okay. So first, let's compare this 10 to the 15. So RU over ST is 10 over 15, which simplifies to 2/3. Next, this 14 corresponds to this 21. So RQ over SQ is 14 over 21. And I could divide the top and bottom by 7 to get 2 over 3 corresponding. And then finally, this 9 corresponds with that 13.5. So you call that UQ over TQ is equal to 9 over 13.5. Okay. This might be a little bit difficult to see, but you could divide the top and bottom by 4.5 to get 2 over 3 as well. Or if you punch it into the calculator, 9 divided by 13.5, you're going to get 0.666, which is also 2 over 3. So now we could see that all three corresponding pairs of sides are proportional. So therefore, we could conclude that triangle RUQ is similar to triangle STQ. By the side, similarity postulate.